Okay, so today we'll be looking at capacitor and capacitance. So this is what we'll be dealing with. So let's start by definition. What is capacitor? We say here, as you can see written, capacitor is an electric device that stores energy by collecting and holding electric charge on two conducting plates separated by an insulating material called dielectric. So from from this diagram from this diagram you can see that we have plate 1, the upper one, the last one is plate 2, and in between plate 1 and plate 2 we have what is called the dielectric. That's an insulating material that separates plate 1 and plate 2. So the dielectric is represented by D, and on plate 1 you can see a terminal, that's the positive, and on plate 2 you can see another terminal, the negative, and these in turn can be connected to electrical energy for different purposes. Okay, so we can now say capacitance. This is the ability of a capacitor, that's ability of this capacitor to store charge, and the capacitance is measured in what we call farad, F, capital letter F. So the symbols below, let's now consider them. We can see for this we have a fixed capacitor for this symbol, and this symbol is for a polarized capacitor. It has polarity. This is the positive and this is the negative side, and this is a variable capacitor. Alright, so let's proceed to an example and now see what we can do. But before we dive into an example, let's define some terms like electric charge, and then show you some formulas that we will be playing with in our examples. So let's now dive in and see. Alright, let's see now the charge Q. We represent charge with Q stored in a capacitor is given by Q is equal to I by T. Q is equal to what we say I T. Measured in what? It's measured in coulombs. Charge is measured in coulombs, capital letter C. Coulombs. So where we now say where I is equal to the current and what T is time. This is measured in what? Ampere. This is measured in seconds. So capacitance now. The capacitance of a capacitor, capital letter C, is equal to charge over voltage. That's the potential difference. Q is equal to charge measured in coulombs, and voltage, potential difference, voltage measured in volts. So that's that. Let's now have an example. Let's take an example. So this is the question we have before us. It says A, determine the potential difference PD across a 4 microfarad capacitor when charged with 5 millicoulombs. B says find the charge on 50 picofarad capacitor when the voltage applied is 2 kilovolt. This is 2 kilovolts. So let's now say solution. Let's say A. We'll now say capacitor was 4 microfarads. Right, 4 microfarads. Micro means what? 10 raised to the power minus 6. If you can remember from our previous class of prefix, you can get this. If you haven't watched that, you can go back to that and watch, so that you would have an understanding of the prefix we'll be using here today. And charge Q is equal to 5 millicoulombs, which is equals to 5 milli means what? 5 times 10 raised to the power minus 3 coulombs. So we now say, since we're now solving, since capacitance C is equal to Q over V, if you remember, we can now say, let's make V the subject. V is equal to Q over C. Remember, in question 1 we were asked to find the potential difference, determine the potential difference where V is same as potential difference. You can say PD, potential difference, or V is equal to Q over C, which is equal to what? 5 times 10 raised to the power minus 3 all over 4 times 10 raised to the power minus 6, which is equals to 0.005. Yes, if you do that, this would be 0.00000 after this decimal point 4. So hence we can say PD, potential difference V, is equal to 1250 volts, or 1.25 kilovolts. So that's that for A. We've calculated it. Let's now solve for B. We were asked to find what? Find the charge on the 50 picofarad capacitor when the voltage applied is 2 kilovolts. So we can now say capacitor C, the value was what? The capacitor, so was what? Was 5 picofarads, which is the same thing as what? 50 picofarads, rather 50 picofarads, which is equal to 50 multiplied by pico is 10 raised to the power minus 12 F, if you can remember. And we would now say V is equal to what? 2 kilovolts, something as 2000 volts. So remember, from C is equal to Q over V, we will now say Q is equals to CV. Am I correct? So what do we have here? We would have 50 by 10 minus 12 multiplied by 2000. So charge now be equal to what? 0.123456 coulombs, or Q now will be equal to 0.1 microcoulombs. That's that for B. So let's now look at another example. Alright, this is the second example we'll be looking at, where the question says a direct current of 4 amps flows into a previously charged 20 microfarads capacitor for 3 milliseconds. Determine the potential difference between the plates. So let's proceed. This is a solution. What's our data? Our data was I current was equal to what? 4 amps, and the value of the capacitor was 20 microfarads, which is the same thing as 20 times 10 raised to the power of minus 6, and time t was what? 3 milliseconds, which is equal to 3 times 10 raised to the power of minus 3 seconds. This is the same thing. Remember that Q is same thing as IT, we said, right? So which is same thing as what we say 4. That's our I now current, 4 multiplied by what's the value of our 3 times 10 raised to the power of minus 3 seconds. Am I right? Seconds. So we can now say we were asked to find or determine the potential difference between the plates. So potential difference V is equal to Q over C, right? We have now maneuvered to get our Q, and we have our now C over there. That's the value of our capacitor that was charged Alright, so we now go further, saying 4 times 3 times 10 to the power of minus 3 all over what? All over 20 times 10 to the power of minus 6. This would be 0.012 all over 0.00000. Yes, so if you do that, you'd have 600 volts. So potential difference between the two plates is 600 volts. So that's that for our second example.